Bom, boa noite a todas e todos. A gente está aqui com mais uma atividade do nosso curso, né, de formação de professores do Programa Interinstitucional de Ciência Cidadã na Escola. Para aqueles que não me conhecem, eu sou o Rodrigo Reis, atualmente sou o coordenador geral do PICCE, né, do Programa Interinstitucional de Ciência Cidadã na Escola, sou professor da Universidade Federal do Paraná, do Departamento de Biologia Celular da UFPR, atuo também como coordenador do Programa Laboratório Móvel de Educação Científica da UFPR, e é com grande prazer assim, que a gente traz, né, ou que a gente apresenta essa atividade, com a participação de uma professora, né, que é uma grande amiga nossa, que é a doutora Russanne Low. Eu vou dar uma lida no currículo. A Rusty, ela trabalha com Ciência Cidadã, né? Então ela é formada com seu doutorado na Universidade de Minnesota, com estudos interdisciplinares de arqueologia, geografia, geologia, ecologia e antropologia, com estudos da paleoecologia do quaternário, com uma área de concentração aí sobre paleoclima. O mestrado dela ela fez na Universidade Ludwig Maximilian, em Munique, e a graduação em antropologia na Universidade do Maine. Atualmente, né, a Rusty ela trabalha como cientista sênior para ciências da Terra e extensão, né, e também coordena aí é cientista líder do consórcio para a educação científica, a educação em ciências da Terra da NASA. A Rusty tem uma grande experiência, ela foi uma das responsáveis pelo desenvolvimento, né, a principal responsável pelo desenvolvimento do protocolo do Mosquito Habitat Mapper e pelo desenvolvimento do aplicativo do Globe Observer, ao qual o protocolo do Mosquito Habitat Mapper faz parte. A gente teve o prazer de ter a Rusty como pesquisadora Fulbright no Brasil no ano de 2022, ela passou aqui 2 meses conosco no Brasil, que coincidiu muito com o processo de implantação do Programa Interinstitucional de Ciência Cidadã na Escola, o PICCE. Então, a Rusty é uma colaboradora, uma cientista parceira, e para nós é uma grande felicidade poder trazê-la para fazer e ministrar essa atividade do curso de formação de professores do PICCE. A Rusty vai falar inglês, né? Ela já arranha o português, mas ainda não com fluência, então eu vou pedir para todos aqueles que estão no YouTube que vocês liguem a legenda, né? A ideia é que a gente possa trabalhar com a legenda para poder acessar a tradução da apresentação da Rusty. A gente vai pedir que aqueles que tenham perguntas que façam as perguntas como comentários. Essas perguntas a gente vai trazer para o final da apresentação, e aí eu vou trabalhar junto aqui com o Jailson, com o Luiz, para a gente fazer a tradução dessas perguntas e o do diálogo junto com a Rusty. Então, Robson, vou pedir para você colocar... dar boa noite para o Robson, né, que está com a gente aqui. Pedir para você incluir a Rusty na tela. So, Rusty, good night. I'm very glad to have you with us in this course. Most of our public is from teachers that work in the PICCE program and collaborate for us. So we are very happy to have you again with us. I was talking that you stay with us in Brazil last year, last in 2 months in a Fulbright partnership. So it was really happy. We were really happy, and we learned a lot with you. So Rusty, please feel free. You have all the time that you need to make your presentation, and we'll be here. I will pass your slides. So when you want, just give me the next sign, and I will pass your presentation. Okay?
Ok, obrigada, professor.
Yeah, de nada. You are always welcome.
Okay, so boa noite a todos. I guess we can start. Thank you. So welcome everyone. Today I'm going to talk about citizen science and why it is one of the best ways to teach about science in your schools and why it is so important at a global level to address the problems we have with making sure we have a sustainable planet. Next one. So this is just, I think, Rodrigo, Professor Rees already introduced me. Most recently, I have been working with UNITAR as a global diplomacy fellow because they are very interested in the role of citizen science for the UN Sustainable Development Goals. And I'm going to talk to you today about PICCE and about this other very important global way we have to address the changes we are seeing in our world, making the bad changes better and encouraging a better future. So let's go to the next slide, please. And this is the point of the whole talk today. The Earth, not just your students, not just PICCE, we need citizen scientists now. We can do this because we have mobile devices and we have incredible programs that have been developed in regions like in the state of Paraná, which PICCE. And what it means is that all these young people can help us solve these problems. We know that learning about science is most effective when people actually do science. And citizen science programs like PICCE help people to do that. But importantly, besides just giving our kids an opportunity to really learn science, to really gain the computational literacy they need for the future, they're also collecting data that is critical for decision making on our planet. Next one. So let's take a global view. So citizen science is a very powerful way to learn science, technology, engineering, and math. And to do this, we can focus on the engagement of our young people as a way to make the world a better place. Citizen science has been identified as a really powerful way for us to address and meet the UN Sustainable Development Goals. And as a result, I want you to know that as educators in the PICCE program, your work is very, very important to students, to your community, and to the globe. Next one. So, I am coming from a place where I've been involved in citizen science for a very long time with students. The program that I'm involved with is the GLOBE program. It started in 1995. I got my PhD in 2001, and I immediately became involved in this program. There have not been many programs that are well-designed that look at a bunch of different aspects of the environment in one program, and is also something which has been designed for student participation. But GLOBE is one. There was a wonderful program called OPAL, which was in Britain, that also was used a lot by students, that ended in 2019. And today, of course, we have the PICCE program. Next one. So this is not a talk about GLOBE, but I'm telling you that GLOBE is really been successful. It's in 127 countries, including Brazil, 38,000 schools, 43,000 teachers, many citizen scientists, couple hundred million, thousand, millions of measurements. So this is what a successful citizen science program looks like. And what PICCE does is it took the model, a lot of the model of the GLOBE program, but it adjusted it to meet the real questions that are important for students and community members in the state of Paraná and southern Brazil. Next one. And this is one reason I was so excited to be invited to help work with this project. Brazil has always been an important partner in GLOBE. It is managed by the Brazilian Space Agency, AEB. And in fact, this Globe Observer tool, this handheld platform we have, was actually tested and beta tested in Brazil and also Peru about 5 years ago. So that is how I got to know Professor Reis, how I became involved in Brazil, and why I'm here talking to you today. So let's look at the next slide. And the reason, of course, that we want to do citizen science is not only to understand the science of our environment and the science about health, but students really benefit from this. We know they learn a lot. They develop science capital. You know, they are able to be a part of, they can contribute to decision-making in our society. Citizen science also is a form of environmental justice. So those individuals who are disenfranchised, that do not have access to a lot of the resources that others may have, they can get these resources through participation in citizen science programs. And importantly, this is a way not only for students to learn about science, but also engineering and computer science. And this opens a lot of jobs up to our young people. Next one. So I thought the first thing I would do is tell you some data, because it's data that convinces scientists and teachers like ourselves why this is a good approach. And we recently published a paper in Frontiers in Environmental Science. And what we did here is we evaluated the outcome of a environmental citizen science program that was located in the communities where students were found. We worked with 100 students that were between the ages of 16 and 18, and they were involved in a 2-month research experience collecting, analyzing data, and presenting their research to each other and also to the scientific community. And these are things, of course, that PICCE students are doing as well. Thank you. Next one. So these are some of the outcomes. We did an evaluation. We did what we call pre-testing and post-testing. So we asked the same questions of the students before they did citizen science for the first time and then after. And I don't need to show you lots of graphs, but what's important is there was a statistically significant increase in these students in the science knowledge of the things that they were studying. There was an increase in their interest in science, specifically in the sciences that they were studying as part of the citizen science. And actually the highest increase was an interest in doing science or even having a career as a research scientist. So these are very powerful outcomes of just a 2-month program with citizen science. So we know the data is there, and this is why I think citizen science is so important to have in every school in the world so that we can get kids that understand and trust and can use science data. If we go to the next slide, please. I have a couple quotes here from the students. I don't think I need to read them completely, but what they said was, my research was important to my community and it was really motivating for me. I knew that what I could do had a direct impact on the people I know. So that's one reason why citizen science done locally is important. It's very motivating. Another thing that the students mentioned was they felt it was important that they could contribute to their community through their own research. One student said, I love my community. I love community service. I was excited to begin my research and do it in my community. And before this, I didn't care very much when I was just thinking about science, sort of, without having a hands-on experience, thinking about it in a textbook. When I was out in the community, it made a difference. And then an interesting conversation from another student said, I see my community differently. And this individual said, honestly, at first, I wasn't motivated to do research in my community because I didn't really like it. I had a negative stereotype of my community. But I changed my mind as I began to study the history and the environment of my town. I started realizing how rich my town was and how there were certain resources here that are rare in other areas. So these are very empowering statements by students and we know that if students care about what they learn more deeply and they learn better. And so we are able to activate the emotions of students by getting them engaged in doing science in their communities. Next one. So these are the outcomes of this study. We found out that that citizen science programs, there are citizen science programs that are incorporated into school curriculum, and this is a very positive thing. We know that from research that people who are studying about science in the place where they live is very effective because it allows them to make what we call a real world connection between scientific research over here and human lives right here. And we have something we call in English a sense of place. And this is described as the emotional reaction that we have between a person and a place that they live or a place they care about. And this is a powerful tool that teachers and educators can use in motivating learning. And a recent study conducted by NASA said that there are also societal benefits, that these citizen science programs can create opportunities for communities, especially those that don't have a lot of economic resources or are somehow otherwise marginalized. And it gives them an opportunity to have real contact with scientists, to find scientists to be mentors, to improve their science capital, and connect with the science community. So all these things are really important outcomes from programs like the one I was running here in the US and the one that you are running in southern Brazil. Next one. So I wanted to let you know that your work is really important. And in fact, the world already knows about it because this year, myself with some of my colleagues, we presented at the UN General Assembly Science Summit. And we talked about environmental science diplomacy through education and talked about the role of citizen science as it helps us meet those UN Sustainable Development Goals. And PICCE was talked about in the UN. Next one. So citizen science is one kind of science. There is also science that's done on the lab bench where you're pouring chemicals. There's science that's done on a computer by moving algorithms around. But citizen science is good for certain kinds of research. In fact, it can be the best way to do certain kinds of research, especially projects where you need a lot of data over a large spatial area geographically for a long period of time. And so citizen scientists can provide the velocity of information, a lot of information coming in more quickly than any one scientist or team of scientists could do. They also can provide the volume of information, far more information than a single scientist team could do on their own. And they can also provide validated, accurate information. And this happens because they are following protocols like the PICCE protocols that you have access to for your classes. Okay, let's go to the next slide, please. And so you are familiar with this. This is just my one slide showing all the people that are supporting this program. And next one. And I will show you that what's really exciting about PICCE is that it maps very well to the Sustainable Development Goals. So here you see the 17 Sustainable Development Goals, and you see here 10 of the 16 protocols of PICCE. And so this is very great because the work that students are doing is really helping us with these goals that we have worldwide. Next one, please. So for instance, I think all of you are familiar with this wonderful book that was been put together by your PICCE team. I put this one first because I work with the mosquito habitat mapper with Globe. And we all know that right now, across all of Latin America, including Central America and South America, we have a huge dengue pandemic. And the organizations that are really responding to this, the Pan-American Health Organization, the World Health Organization, the Center for Disease Control in the US, all of them say we need citizen scientists and communities to do surveillance and mitigation. And that is exactly what you are doing in the PICCE program if you are monitoring the habitats of that dangerous mosquito that causes dengue, Aedes aegypti. Next one. And I just wanted to show you this beautiful photograph of the Zika bus. This was an idea that came out of some of the work that we were doing together in 2017 and was taken on by Professor Reis, and he made this happen. And this bus will go to different communities and support the UN Sustainable Development Goal of global health and well-being by teaching about the dangers of mosquito-borne disease and how communities can deal with this by making citizen science observations. Next one, please. And so in this bus, there's a mobile classroom, there are exhibits, they set up tables, they get people involved in collecting data. And it's a great way to get education out into the community, which of course is another Sustainable Development Goal. Okay, so now I'm going to give you another example, please. Next slide. And that is land cover. Now, in my mind, land cover is maybe the most important citizen science protocol in Globe, and it's also an incredibly important part of PICCE. And it helps us understand what's happening on the ground, life on land. It helps us understand changes in climate and environment, and it helps us understand the sustainability of our built environments. And so this is a really critical piece of the work that you are doing. And it's also something of great importance to the UN SDGs as well. Next one, please. So with respect to this one, there are so many, if you have your students doing the land cover protocol, which I understand they actually look at this when they do every protocol in PICCE, that data can stand alone because you can ask questions from that data, like from one year to the next. What is the degree of change in land cover in my city? We actually have satellite data since 1984, which is readily available. So you can look at where you live today and the data that your students collect and compare that to images taken 84, 94, well, 40 years ago, right? So that's really incredible. You can also look at the differences between the height of trees and forested areas in the city. How does this translate to biomass? How much carbon has been sequestered and how much carbon has been removed? This helps us better understand what's causing climate change. You can begin to use these data to understand conservation and sustainability. And you can also use your data to test the validity of land cover maps that come from the European Space Agency satellites or the Brazilian Space Agency satellites or the US satellites. So it's very, very interesting work that you students can do. Going to the next slide, please. I just wanted to give you just a short view of what we did last year when I was in a town called Óbidos, which is on the Amazon. And we worked with students for a week and got them involved in doing citizen science to help understand the changes that happened in this town over the past 30 years. Next one. And just to show you that what we do is if you talk about a satellite image, we talk about it in terms of pixels, right? The pixels that you get in a computer image. And in this little town at the tightest part of the Amazon, we had students go out and do a grid and document using a camera phone what the land cover was like. And so you can compare what students have found with these satellite images. Next one. And they found some very interesting things. So the little brown dots here are all the places where students actually use their camera phone to identify the land cover. And then we talked about the changes that had occurred there. And importantly, where we have this yellow triangle, this is an area outside the city where there's a lot of illegal clearance of the Amazon rainforest. And so this was something they were able to document using this tool. And they also were able to document changes that have happened just because of urbanization over the last many years. Next one. And just to show you that the data that you collect can be accessed and compared to maps that are provided by space agencies. And you can also create maps where the photos that you take can be displayed on a map. And these are functionalities that I hope that we will be able to make happen when we have a PICCE app. Next one. So it was important work. We brought these kids together. They looked at the land cover in the field, then they looked at the land cover in images that come from the Brazilian Space Agency. They looked at local issues, and they also increased their computer literacy, being able to access and analyze computer data. Next one. The last example that I'm talking about today is the Araucaria Hunters Protocol, which is also one of the PICCE protocols, which helps us understand climate change and life on land. If you go to the next slide, please. One of there's many, many sad things that are happening in our world. And one of them is the fact that the Atlantic rainforest was once quite substantial. It has decreased in size over the many years. And as a result, this beautiful, iconic tree is now in danger. They say today there's less than 2% of the trees that were ever there in the first place. So it's really important for us to know where all these trees are and to follow their health so that we can better understand what's happening. And there's a lot of changes because of human activity by industrialization and expansion of our cities, but also the araucaria tree has beautiful wood. The nuts are a fantastic food source for both people and animals. So it's a very iconic, a keystone species, and yet it's under danger also by climate change because it needs those wet areas in order to survive. Next one, please. So the Araucaria protocol was developed because of, I think there a strong piece of this was that the GLOBE program had a tree protocol. And then sitting around talking with students and scientists at the Federal University of Paraná, we came up with the idea, why not a protocol, not for all trees, but just for this one tree that's so important in this area. And I think that's why the PICCE program is so important, because it is something that is absolutely designed specifically to answer questions that communities have and students have about where they live. Next one. So I've given you some examples of how the protocols that you have in the PICCE program connect to the Sustainable Development Goals. And this is something that I think might be very interesting for you to communicate to students as well, because I have worked with a lot of students. I think I've worked with about 500 students over the past 5 years here in the US. And these students are very interested in the environment and in sustainability. And the UN has put together a game, actually, a sustainable goals game that you can download and do with your students so that they can better understand the science that they are doing with the PICCE program and connect it to what we're trying to do as humanity to make our whole planet sustainable. Next one. And so I put in this next slide the URL where you can find this game, but there's a game board. They have a bunch of different questions that the students can answer. You can build a dice that you can use to throw. And then there's also rules to how to play the game. So this might be a very nice way to introduce a little fun into the science you do and help the students understand that the science that they are doing is not just so they get a grade in your class, but actually it has a much, much broader and much, much more important outcome. And so I was really pleased to find that this game is available in Portuguese. Actually, there's actually a special version for Brazilian Portuguese, so please enjoy. Okay, next one, please. So once again, just to show you some of the areas that the PICCE program has protocols where students can collect data. These are so well connected to the Sustainable Development Goals, and this is something that we want to continue to pay attention to. Next one. So this is not, I wish it were, but this is not my own idea. This is something, in fact, that has been talked about quite a bit in the scientific literature. The most salient paper was in Nature Sustainability, just about 4 years ago. And it was an article about citizen science and the UN Sustainable Development Goals. And they make these 3 really important points. That is, the traditional data sources that we have to track the progress that communities are making towards the Sustainable Development Goals is not sufficient. We need more data. So citizen scientists can do that. And these new non-traditional sources of data can be collected by citizen scientists. as well as, importantly, our youth. So they will also get involved. And so we have now also, it's hard to remember this, but we are in a data revolution. And what that means is that we now have computers that can work really fast and work with a lot of data. And so, whereas 20 years ago, it wasn't so important, today we can actually work with all the data that citizen science are collecting. So these are really important points that make citizen science so important for the UN. Next one, please. So citizen science is important because one thing it does is it is inclusive, that every student in your class can contribute. We call this collaborative intelligence or shared intelligence or community intelligence. And importantly, there might be a student in your class that comes up with a solution to an environmental problem in their community that might help us for the whole world. We don't know. But we do need knowledge from everyone in order to address this huge problem that we have today, the challenges of today's changing planet. And so these are the important things. This is sort of the big, broader context of the work that we're doing with PICCE and with the GLOBE program. Next one, please. So we are now fostering citizen engagement. We are getting citizens involved in ways that they can actually contribute to policy decisions in their communities. We talk about how citizen science helps to democratize science or make it more available to everyone, so everyone has hopefully an equal voice. And finally, we can raise awareness and mobilize action in our communities about the problems that we're facing today, whether it is the problems of a landslide, or the problems of a dwindling population of araucaria trees, or the problem of water quality, or beach trash, or dwindling pollinators. The PICCE program has really identified those most important problems where students can make a big impact by collecting data. Next one, please. Next one. Thank you. So the next slide is coming. So I think I've said this too many times. I think you're bored with it now, but citizen science can change our planet health. It provides data. It helps us all understand the problems. It shares knowledge. The data can be used by sophisticated scientists that are running models. It can help answer research questions. It can introduce new methods and philosophies from the citizen scientists themselves. It creates advocates about the environment amongst our youth. And it connects people and their governments and the environment all together. So these are all great reasons why we want to do citizen science in the classroom. So thank you. The next one, please. So I started this talk by discussing the outcomes of citizen science from a educational perspective. And I gave you an example of a study that we have just completed that demonstrates that unequivocally. So we know it's great for students. We also know that globally, organizations like the UN are very interested in your citizen science data. And I think I have communicated how unique the PICCE program is. As far as I'm aware, there is no other program besides GLOBE and PICCE that have many different protocols that are available for students, designed specifically for students, so that they can contribute to the health of our planet. And so I want to thank you for the work that you have done in your classrooms to promote citizen science. And I hope that in my role as a scientist, I'll be able to meet with your students and give them an understanding of how appreciative the science community is and how welcoming we are of the work that they are doing. So I think it's time to have some questions.
And I'm back to the screen. Okay, so Rusty, I'm following in the YouTube, so we have a lot of questions, at
Okay,
least
good.
6 or 7 questions.
Fantastic. Good.
Okay, so Robson, can you please put the first question? Oh, Marcelo, he did it already in English.
Marcelo, thank you for your question, and thank you for doing it in English, because no falo português. So there is not good, I will just say at the outset, there really is not good longitudinal data on students who have participated in citizen science projects. The reason why is there are not that many programs that have done this with students. Now, there's the caveat, which is the GLOBE program. And the GLOBE program now has been around for 25 years. And we have GLOBE students that have gone on to become teachers and scientists, and they have personally attested to the importance of these programs. But because this program, this is a limitation that we have that you will not have. The GLOBE program, because it's in so many countries, it's very difficult for us to gather all that data and make sense of it, because there are different ways that different countries evaluate progress in learning. So you can find individual studies like the one I just did that tells us a little bit about this. But right now, what we have is this anecdotal evidence that, yes, in the GLOBE program, which has been around for so long, we have kids that got excited about science in GLOBE, went on to decide they wanted to do a science career, and either became educators, which are incredibly important, or became scientists, or even gone into policy and diplomacy because of their role in citizen science. So I wish I could say we do have good longitudinal data. I think that there probably is data, but it hasn't been worked up yet. So I want to thank you for your question.
Thank you, Marcelo.
And Rodrigo, I think that is something that you can put on your list of research projects.
Yeah, but I think that sometimes will be, because we cannot identify specifically who is the person who will collect the data because of ethical issues. So sometimes it will be hard to have these informations or to follow which student is collecting data among the time, because we cannot identify the student or the citizen who is collecting this data. And
this is the problem. This is why the only data that I have is what we call anecdotal evidence, right? Where the student has said, I was a GLOBE student in Croatia back in 1980, and I am now a professor of biology. One of the students that I worked with many years ago in the 1980s became a teacher, and now she is a principal of a school, a science school in New York City, and she has her PhD. So if people self-identify, then we are able to see, yes, there has definitely been an impact, but a statistical analysis will be very difficult because we can't get everyone for the reasons, because we protect the privacy of our participants. Thank you for that.
Yeah, now we are developing the app from the PICCE. So every student, they can create their own login to submit the data. and we don't collect any personal data. Even the email, we don't collect it because of this ethical procedure.
Same with us,
So,
yes.
especially for kids, because we will not be able to identify who kids are collecting data. And this is something, once the data should be open, because we are talking about open science. So we have to manage a way that we will not be able to collect the personal data from the person that is collecting or applying the protocol.
Yeah.
The next question is from Joseine. Rusty, how is your opinion in relation to the scientists that don't believe in global warming?
That's a wonderful question.
They said that global warming is not real.
Yeah. Josine, thank you very much for your question. I don't know if I think I heard Rodrigo talking a little bit about my background. And so I think I can speak to this very authoritatively as a person who was trained in climate science and climate research, paleo climate research. But what I can tell you is those scientists that study climate, more than 99% are of the opinion that there is no question that human activity is responsible for climate change. And if you're ever interested, I'd love to give a talk about this. This is something I care about a lot. The data is very clear, especially when you look not just at the last 10 years or 100 years, but if you look back 400,000 years, you will see that what we are doing today with fossil fuels has dramatically changed the CO2 levels and the temperature on our planet. And there is no other answer. I do think we do have evidence that there are people who identify as scientists, but they are not specifically involved in this kind of science, that have been able to attain what I want to say notoriety. They have become famous by saying, I don't believe in this. And so then there are businesses and factions that want to have a spokesperson, and they've chosen these people. They generally do not have the credentials. So I will say in my entire career, dealing with people that study climate change or study climate period, I have never run into anyone who actually does not believe that climate change today is caused by humans. I do know of one or two that I have read, but I have met hundreds and hundreds of scientists, and it's just not what scientists believe. So I hope that's a good answer. It's difficult because it's political, but it's, in my mind, it's science data is the issue. The data is unequivocal.
Okay, we have another one. It's about global warming again. It's from André, and he asked you if let me see how I translate that. Talking about the global warming, do you think that the real risk that you have from humanity, talking about global warming, do you think that this is a way that can help or can bring the people to be more connected to environmental issues?
Thank you, Andre, for your question. And I think that's very deep thinking on your part. Yes, I think that as a group of humans on a planet, this is exactly what the UN does, because the UN is bigger and more representative than just the Brazilian government or the American people or the people in Croatia or something. That we all are united, with the prospect of wanting to protect the planet and wanting to have a sustainable environment. Now, the problem is everybody has the constraints of their own economic system. So the progress we are making is slower than I would like. So I can only speak for me. But my hope is that by getting more of our youth involved in understanding what the environment, what's happening in our environment, we will be able to come together as people around the world to solve this problem.
Thank you, Rusty. Jailson or Robson, I think that Marcelo did this question on the end of the chat in English. I think it'd be better if you push the English version of the question.
Okay. What do you think about the relationship between science teaching with curricular standardization? Wow. That is really such an interesting question. And I will speak only for myself, but I will talk about what's happened in the US. And I am not I do not work in a school district, and I'm not currently a teacher. So I have taught for more than 20 years as a university professor, and I've taught teachers, but I have never been a teacher of high school students myself. Okay, so having said that, I think there is a challenge with the curricular standardization that happened in the US. I'm hoping that maybe in Brazil, it might be a bit more enlightened. What has happened? What's happened in the US? Globe was a very active program. We had lots and lots of students doing Globe. Then what happened politically was that there was a movement to improve our test scores, and the people making those decisions decide the best way to do that was to have what we call high stakes tests. Right? So students have to memorize a lot of things and then take these multiple choice tests. And teachers, afraid of their students not performing well, would say, oh, I'm not going to have them go and collect data about water quality. I'm just going to teach them that the pH of water is 7 if the water is good, because they'll answer that on the quiz, right? So this is the problem that we have faced because we have had this standardization of our curricula in the US. It's done by district. We don't have a national curriculum. But what has happened is the opportunities for students to learn science, learn it deeply, and to care about science by doing science, we're doing our students a disservice because they are getting the same textbooks that I got. In fact, they may be actually the same textbooks. 30 years ago, we have a lot of really old textbooks that students are still using, and they are memorizing answers without truly understanding or connecting with science. So in my mind, I would prefer that teachers would have more of an opportunity to teach what they think is important, to teach to their students' interests, to the local problems in their community, and have that the way that you get kids excited about science, than to say, okay, everybody in the US has to learn about the Grand Canyon, even if you live in the flatlands of Kansas and you've never seen a rock, you've just seen grass. It doesn't make sense to me. So yeah, I guess I talked too long about that one, but I think it is a problem. I think teachers should have the opportunity to do what they think is right, because they know the students better than the people who are making decisions sometimes are. Once again, only for myself. I can't talk. Yeah.
I think that it's a big challenge for us in Brazil because we have now a national curriculum. So even in PICCE, we are trying to say how each protocol talk with this national curriculum about what subject or which topic of the national curriculum this PICCE protocol, every PICCE protocol can talk or can be used by the teachers. So this is a challenge that we have and we are trying to manage this, showing to teachers, or even on these booklets that we have, how you can use this and how we can relate this with the subjects of our national curriculum.
And yeah, and I think that's what we've done with the GLOBE program too.
Yeah.
We have gone through the GLOBE program. We've aligned our protocols to different science standards that we have. But I will just tell you quickly, I have a personal experience with this, because when my son was 8 or 9 years old, he was in a school which was a science school. It was, and he had a teacher who loved monarch butterflies. And for 2 years in their science class, they did monarch butterfly citizen science. And you would think, oh, this poor child, he only learned about monarch butterflies. He didn't learn about bears or other animals, or didn't have a geology class. But because the kids got so excited about the research that they were doing with those monarch butterflies, he learned more about science with that topic than he would have if he read a chapter about rocks, and a chapter about water, and a chapter about insects, and a chapter about climate change, because it was all contained in what they did. And seeing that as a mom really was one of the motivations I had to really spend a lot of my career fostering citizen science for kids.
That's great. Yeah, it's good. It's a great relate. We have another one.
This is a good question. Thank you, Jailson, for asking this question for Teo. And yes, so I think maybe this would be a question that Professor Rodrigo could probably answer, because yes, eventually all the data that is collected is going to be open and available. And in my program, which is 25 years old, we have all the data that's collected by our students is uploaded into a database. And I know that is the goal of the PICCE program. I don't know where you are yet in that.
Well, on the next year, we make the renovation of the project. We are planning to do the artificial intelligence from the project. So the data that will be collected will not immediately be available for everyone. We will have 1 year where the data will be checked by specialists from each protocol. So they will check if the data makes sense, if the picture that came, it's a good picture that represents, for example, a bug or represents the tree. And after that, we expect to use these data that are validated to make the machine learning from artificial intelligence. So I think that the next year will be the year of the validate, where we have a team to validate all the data. When the data are validated by these specialists, they will be available to be free access, like open access for everyone. And then you can use the data that you collect, for example, in Curitiba, and compare it from the data collected in Foz do Iguaçu, for example. That will be available. But the next year will be used to training our system to validate all this data. I think there's something like you did in Globe also.
It is, and we hope to share with the PICCE program. We have had 3 projects funded by NASA's Center for AI Excellence, of Artificial Intelligence Excellence. And they have developed some very robust algorithms that can be used to label images that come from the land cover protocol. And so we're hoping to be able to share that AI with you guys.
Me too.
So we also have been working on another project. I've been working with the National Science Foundation and my colleague, Dr. Ryan Carney at University of South Florida, and his his AI specialist, Dr. Sriram Chelapam, and they have developed AI to recognize mosquito larvae.
Oh.
And this is it's sort of the same thing that you just mentioned, Dr. Rodrigo. We've developed it, it's working, but we're not sending the information back because it's still in development. But this is another AI tool that I hope that we can share once it becomes hardened, I guess, and reliable.
Yeah. It was a good question.
Very good question.
Yeah.
Is there a specific protocol for health education? Does your research group work with health education specifically, or take it? Okay, this is a great question. Thank you, Fernanda. I know that with respect to health education, there are 2 protocols in PICCE that address this. I think it is one of them is looking at obesity and foods. The other one, is there one also about dangerous substances?
Yep.
Yeah.
It's about the presence of advertisements about drugs and dangerous substance.
Right. So these are examples of really wonderful protocols that were specifically designed with the PICCE program that we don't have in the GLOBE program. Because GLOBE is funded by our space agency, NASA, their interest is really on changes in the environment. And so we don't have in our program the focus on health that is so important and so important that you guys are doing in southern Brazil. So I'm looking forward to seeing what comes out of this work. Also, though, we have done some work looking at how well do people learn about mosquitoes using the mosquito habitat mapper, which is connected closely to your mapping habitats of Aedes aegypti. And so we are able to track and see that people really have learned a lot about health education when it comes to protecting yourself from mosquito-borne disease. And we did this research actually in Brazil, as well as in Peru, I think in 2018, and we had very positive outcomes. But except for mosquitoes, we're not really doing much with health.
Yeah. I think that one of the interesting things that we have of these 2 protocols from PICCE is because these 2 protocols, they were asked us from the Education Secretary from Paraná State. So they said, okay, we would like to have a protocol that talk about obesity and another one that talk about drugs. So we opened and we developed these protocols, and we had to change it in the way where we will not collect personal data from the students, or even if we could identify, for example, which school we have the students with more access with drugs. So we have to change the subject to fit these protocols in open science project and citizen science project. So it real challenge to do this. So we not work specifically about this topic, but we use the team, the big topic to work in school about this.
This is important, and I think you keep pointing out, Dr. Rodrigo, the importance of how citizen science is really a fundamental tool of this idea of open science that is now being embraced nationally. And because the data we collect is very valuable, but we have to make sure that it is not misused, and you cannot recognize individuals. We have to protect everyone and their privacy. And so it is a challenge, and it does also mean that we have to, like you say, design the protocols around privacy and protection of individuals, and prioritize that over even the science. Right.
We have another one. Let's see.
So I can't, because I'm sorry that I can't answer this one because I am not in Brazil and I don't know your national curriculum plan, but maybe Dr. Rodrigo could address this.
Yeah, Andre, I think that it was like I said before, we have to make some flexibilization of the protocol to say, okay, you can work with these protocols on this special subject of the national curriculum. So we take care of this in the PICCE educational materials to help the teachers and the schools to how they can use this in national curriculum. But sometimes it is a challenge because not all the topics that we have or that came from the protocols are directly related with the national curriculum. So sometimes, okay, we can use this approach, you can use talk about this, but sometimes it's not so clear, it's not so directly connected, this relationship. Okay, we have another one. I told you there was a lot of questions. It's okay? Okay, so I think that we have some questions. I'm here in YouTube, so people are asking you if the game that you show, if it's available. I think that you show the link, and we can put this link sometimes in the course platform
Yes.
from teachers, so they can get this material. And also we have another question that asking if the Globe has material from in Portuguese from teachers. I think that we have a lot of material in Portuguese, yep, especially from
There is a lot of
Observer.
material in Portuguese from teachers, and our protocols are pretty much different than the PICCE protocols. So, if you have students that, for instance, that are interested in doing atmospheric work and looking at clouds, for instance, there are excellent materials in Portuguese developed by the Brazilian Space Agency. There are also a lot of materials about the mosquitoes. There are also information about trees and land cover. And I believe also some atmospheric protocols. They have created a book. And I think Dr. Rodrigo can find out from Dr. Lini Veloso the link to where you can find those materials.
Yeah.
But
And
they have
also,
been all translated.
you have in PICCE from Mosquito Habitat Mapper, you have a booklet in Portuguese that you can use to collect data from Observer, because the data that we will collect in from Mosquito Habitat Mapper, they will use the app from Globe Observer.
Yeah.
Yep. So Josine is talking that Dr. Low, you are an inspiration for everyone.
Oh, thank you so much. I really enjoyed very much talking to you, and thank you very much for listening to this in English. It's not so easy, I think, to listen to someone speaking for an hour in a different language. But I hope you got what you needed out of this talk. And Dr. Rodrigo, will you please give people my email so if they have more questions, I am happy to answer them as best I can.
Yeah. Dr. Low or Rusty, thank you very much again. I always told that you are a very important partner from PICCE. This collaboration that we started in 2017 was since now it was great. I'm
We had no
learning a
idea.
lot.
Yeah, then we had no idea that PICCE would ever happen, right?
Yeah,
It
look
was
what,
yeah,
yeah, it was really great.
yeah.
So thank you very much. And I'm sure that will happen, but I hope to continue with this partnership and that we work again. And maybe we can bring you to Brazil next year. It will be great again.
I really hope so, and I hope to visit and meet with some of the instructors and teachers that have been online today and maybe visit some of your classrooms. That would be so wonderful for me to see PICCE in action in your classes.
Yeah, you are our main consultant from the PICCE, so it would be great to have you here again, and we will keep in touch. And thank you very much. Thank you very much for our team that make the course and this lecture happen, and for everyone that is following us in the YouTube. Thank you very much. But I think that was great, and have a nice course until this end. I think that we have already in the middle of the course. Thank you very
Okay.
much.
Thank you, everyone. Have a good evening.
Boa noite, pessoal. Até.
Boa noite.